Hello and welcome to this video for the 2022 Level 3 Differentiation paper for Level 3 Calculus. Similarly to my last two videos, I do not currently have the marking schedule for this paper, so I don't know the exact grade boundaries for each question. However, I will do my best to estimate the grade boundaries based on common past exam papers and past schedules. So without further ado, let's get straight into it. So let's look at question number 1. A, differentiate y equals to ln of x squared. So in this case, we're just going to use the chain rule. So we're going to bring the power down and subtract the power by 1, and then we're going to multiply it by the derivative of the inner function. So we're going to multiply it by the derivative of ln of x, which is 1 of x. So the derivative of ln of x squared is equal to 2 times of ln of x multiplied by 1 over x, which is equal to 2 ln of x over x. And that should just be a simple achieved level question there. It's just simple differentiation should be achieved. Question B, find the x values of any stationary points on the graph of the function f of x equals to x squared plus 1 over x. So for this question, we're going to be using the quotient rule. Alternatively, you can also split up the fraction into x squared over x plus of 1 over x. We can do it both ways, so I'll do it with method 1, quotient rule. I'm going to use the quotient rule. So in this case, we're going to take derivative of the top function, which is x squared plus 1, which is 2x, and multiplied by x. So that's going to give us 2x squared minus of derivative of x, which is 1, multiplied by x squared plus 1. So x minus x squared plus 1 all over x squared. And we want to find the values of the stationary points. So we're going to be making f of x equal to 0. So we just simplify this a bit more. So if 2x squared minus x squared is just x squared. And x squared minus 1 is just 1 minus 1 and over x squared. And the stationary points, we make f of x equals to 0. And therefore x squared minus 1 equals to 0. And x squared equals to 1. So therefore x equals to plus or minus 1. Similarly, we can also rewrite f of x, so method 2, divide through. So we could also rewrite f of x as x squared over x, that's just x plus 1 over x. And if we want to find the derivative of this, we can get f dash of x is equal to, derivative of x is 1, plus the derivative of 1 over x is, 1 over x is equal to x to the power of negative 1, and then you just use the power rule, so this will just be negative 1 over x squared. And similarly, we make equal to 0, so 1 over x squared equals to 1, so x squared equals to 1, so x equals plus or minus 1. So we get the same answer whether or not we use method 1 or method 2, and it doesn't really matter which method you use, as long as you get x equals to plus or minus 1, so that's the answer. And that should be another simple achieved level question. Alright, let's have a look at question number C. The graph below shows the function y equals to square root of x plus 2, and the normal of the function at the point where the function intersects the y-axis. Find the coordinates of point P, which is the x-intercept of the normal. So we want to find the coordinates of this point here. Alright, so to approach this question, we want to differentiate and find the gradient of the tangent at the point of x equals to 0. And we know that the gradient of the normal multiplied by the gradient of the tangent is equal to negative 1. And that's because the gradients of perpendicular lines, when you multiply them together, you'll get a product of negative 1. So we can use that information to find the gradient of the normal. And when we find the gradient of the normal, we can use the point that it passes through, which is the point on the graph, as an initial point to find our c value for our line. And then we can substitute the point of y equals to 0 in order to find the x value, and then we'll be able to find point P. Alright, so first things first, we've got to differentiate our function. So we're going to rewrite square root of x plus 2 as x plus 2 to the power of 1/2. And now we're going to be using the chain rule. So dy over dx is equal to 1/2 of x plus 2. Bring the power down by 1, so negative 1/2, multiplied by the derivative of the inner function. The derivative of x plus 2 is just 1, so that's just 1. And that's equal to 1 over 2 root of x plus 2. Alright, so now we're going to look at the point of x equals to 0. So that's this point here is x equals to 0. So let's plug in x equals to 0 into the equation for the tangent, gradient of the tangent. So we have dy over dx equals to 1 over 2 root of 2. And therefore the gradient of the tangent is 1 over 2 root 2. We know that the gradient of the normal multiplied by the gradient of the tangent is equal to -1. So therefore we have 1 over 2 root 2 multiplied by the gradient of the tangent. So we just say, not tangent, gradient of the normal. So we just call that n. That is equal to -1. So therefore n is equal to -2 root 2. The general equation for a line is y equals mx plus c. And we know that m is -2 root 2. So y equals to -2 root 2x plus c. And we know that the line will pass through the point of x equals to 0, and it passes through a point on the graph. So we're going to substitute x equals to 0 into the equation of the curve. So we have y equals to square root of 0 plus 2, which is root 2. So we know that the line will pass through the point, passes through the point 0, root 2. So let's substitute this point into our equation for the line and find our c value. So square root of 2 equals to -2 root 2 times of 0 plus c. So c equals to root 2. So therefore y equals to -2 root 2 plus root 2. And now we want to find the point P, which is when y equals to 0. So P, y equals to 0. So let's substitute this into our line, into our equation of the line. So y equals to 0. So 0 equals to 2 root 2 times of x plus root 2. So therefore 2 root 2 times of x equals to root 2. So therefore x equals to root 2 over 2 root 2. And root 2 cancel each other out, so we get x equals to 1/2. So now that we have x equals to 1/2, we can simply find the point P, because we know at point P y equals to 0. So point P is simply the point of 1/2 of 0. And this should be a standard merit level question here, because we're working with the normal and working with just equations of the lines and the normal and the tangents. And correct answer at the end here, so point P find correctly, that should be a merit level grade. In terms of getting an achieved level grade, probably if you can get up to somewhere, as in like finding the, let's say finding around the C value here, that might be able to get you an achieved. Or I don't think, maybe if you just differentiate correctly, that could be an achieved, but I'm not too sure in terms of this question. There's quite a lot of steps of this question, so it's not really clear where they're going to be setting the achieved requirement here. Question D, a curve is defined parametrically by the equations x equals to 2 plus 3t, and y equals to 3t minus ln of 3t minus 1, and t is greater than 1/3, because t needs to be greater than 1/3 because ln of 3t minus 1 needs to be greater than 0. For this question, we want to find the coordinates x and y of the points on the curve where the tangent of a curve has a gradient of 1/2. So we need to find an expression for dy over dx, the tangent. And we're going to have two equations in terms of t. So we have x in terms of t and y in terms of t. So notice that dy over dx, that's equal to dy over dt multiplied by dt over dx. So we need to find an expression for dy over dt and dt over dx. That's pretty easy since we have two equations for x in terms of t and we have y in terms of t. So we can differentiate both of these equations with respect to t. And we can rearrange to find dy and dt and dx on dt. And we're going to multiply them together to get our equation for the tangent. So dx over dt is equal to the derivative of 2 plus 3t, that's just 3. And dy over dt is equal to the derivative of 3t minus ln of 3t minus 1. That's just going to be 3 minus of, we're going to use the chain rule here. Derivative of 3t minus 1 is 3. And derivative of ln is 1 over 3. T minus 1. And that is equal to 3 minus 3 on 3t minus 1. dx over dt is 3. So if we find the inverse dt over dx, that's going to be 1 over 3. And now we have all the ingredients we need to find dy on dx. So dy on dx is equal to 1 over 3 times 3 minus 3 on 3t minus 1. And that is equal to 1 minus 1 on 3t minus 1. So that's our equation of the tangent, 1 minus 1 on 3t minus 1. So we want to find when the equation has a gradient of 1/2. So we're going to substitute dy on dx equals to 1/2 and find the t value. So 1/2 equals to 1 minus 1 on 3t minus 1. So let's move the 1/2 to the other side. So we get negative 1/2 equals to negative 1 on 3t minus 1. And we can multiply both sides by negative 1. So we have 1/2 equals to 1 on 3t minus 1. And now we can say that 3t minus 1 equals 2. And therefore 3t equals to 3. And therefore t equals to 1. Alright, so we're not quite done yet, because finding the t value doesn't actually tell us anything about x and y. So in order for us to know anything about x and y, we should substitute t equals to 1 back into our equations for x of t and y of t. So we know that x equals to 2 plus 3t. And we know that y equals to 3t minus 3 ln of 3t minus 1. So let's substitute t equals to 1 into these equations. So x of 1 equals to 5. And y of 1 equals to 3 minus 3 ln of 2. So therefore, the point would be simply, x comma y, which is 5 comma 3 minus 3 line of 2. Oh, sorry, not 3 minus. Sorry, it's not 3. Here's just 1 there. My bad. That's just 1. Okay. So it's just 3 minus line of 2. 1 line of 2. And that should be our final answer for this question. We found the point is 5 comma 3 minus line 2. That should be a merit level question. And very standard, this is pretty consistent throughout the years. If you can find an expression for dy on dx, that should be enough for an achieved. So finding the expression for dy on dx is usually enough for an achieved. Question E. If p is a positive real constant, prove that y equals to e to the power of px squared does not have any points of inflection. So the points of inflection requires us to look at the second derivative, and we're setting the second derivative equal to 0. So in this case, we have y equals to e to the power of px squared. So dy on dx is equal to the derivative. So the derivative of px squared is 2px, and we're going to multiply the coefficient by 2px and keep the power the same. So we're going to have 2px e to the power of px squared. Okay, so we want to differentiate again to find the second derivative. And in this case, we can't just find the derivative of px squared again and multiply by 2px again. In this case, we have two functions, f of x and g of x, multiplied together, where f of x equals to 2px and g of x equals to e to the power of px squared. Therefore, we should be using the product rule in order to evaluate this expression. So recall that the product rule is, if we have f of x, g of x, then the derivative would be f dash of x, g of x, plus of g dash of x, f of x. Alright? So in this case, we're going to find the derivative of 2px first. So we're going to call 2px as our f of x, and this would be our g of x. So let's find the derivative of 2px. That's just 2p. We're going to have 2p multiplied by g of x, which is e to the power of px squared. And the derivative of gx is 2px multiplied by 2px times e to the power of px squared. So we're going to have 4p squared x squared e to the power of px squared. Alright, so we're going to set the second derivative equal to 0. So we have 0 equals to 2p times e to the power of px squared plus 4p squared x squared e to the power of px squared. So let's factor out e to the power of px squared. So we're going to have e px squared 2p plus 4p squared x squared. So notice that e to the power of px squared is greater than 0 for any x and for any real x. And that is because if we take e to the power of something, that has to be greater than 0 no matter what. So therefore, So therefore, e to the power of px squared equals to 0 has no solutions. So let's look at the second bracket. So we have 2p plus 4p squared x squared. So let's set that equal to 0. Alright, so let's move 2p to the other side. So we have 4p squared x squared sorry, equals to negative 2p. So x squared equals to negative 2p over 4p squared. And x squared equals to negative 2 over 4p. So therefore x equals to the root of negative 2 over 4p, plus or minus. Alright, so let's have a look at what exactly p is. So p is a positive real constant. So p is greater than 0. So if p is greater than 0, then negative 2 over 4p is less than 0. That is negative. So if p is greater than 0, then negative 2 over 4p must be smaller than 0. So it's negative. So therefore, there are no real solutions. So there are no real solutions for square root of negative 2 over 4p. No real solutions, so therefore, no points of inflection. And that's the justification that you will need, and that is it for this question, because we've proved that e to the power of px squared cannot be equal to 0, and we proved that 2p plus 4p squared x squared can also not be equal to 0. And that proves that there are no points of inflection, because there are no values of x that can make the second derivative equal to 0. In terms of this grading question, this might be on the easier side in terms of an excellence question, but I still think that based on past papers and their patterns, 95% of the time, the last question is the excellence question. So I would be, so despite it being slightly easier than a standard excellence question, I would still say that there's a good chance that it is an excellence question. So if you can get all the way to the end of the proper justification, that should be enough for an excellence. In terms of getting a merit grade, if you can get up to x equals to plus or minus square root of negative 2 over 4p, that could be enough for a merit grade without the justification. In terms of getting an achieved, I think if you can get the second derivative correct, finding the expression for the second derivative, that should be enough for an achieved. So right here. Question 2. Differentiate f of x equals to 5x minus 3, whole multiplied by 4x, sine of 4x. So in this case, again, we have the case where we have two functions. We can say g of x multiplied by f of x. And therefore, we're going to use the product rule. So f dash of x is equal to derivative of 5x minus 3 is 5. So we have 5 sine of 4x. Plus the derivative of sine 4x is 4 cos of 4x. Multiplied by 5x minus 3. And that should be our final answer. And that should just be an achieved question here. Question B, find the gradient of the tangent of a curve y equals to 3x squared minus 2 to the power of 3 when x equals to 2. So finding the gradient of the tangent, we're going to differentiate and substitute x equals to 2. So dy on dx is equal to 3 times of 3x squared minus 2 to the power of 2 multiplied by the derivative of the inner function, which is 6x. So that is equal to 18x, that's equal to 18x multiplied by 3x squared minus 2. Substituting x equals to 2, so we say dy over dx equals to 36 multiplied by 2 squared is 4, 4 times 3 is 12, minus 2 is 10. So that will be equal to that is equal to that is equal to 10 squared is 100, 100 times 36, add 2 zeros is 3600. And that should be another simple achieved question there. Alright. Question C, an object is traveling in a straight line. Its displacement in meters is given by the formula d of t equals to t squared minus 6 over 2t cubed, where t is the time in seconds. Find the times where the object is stationary. For this question, again, like question A, we have two options. We can either divide through by 2t cubed, or we can just use the quotient rule. In this case, I'm just going to use the quotient rule, just to be quick, just to immediately differentiate. We're going to use the quotient rule. So dt, d dash of t. So d dash of t is the same as v of t. So v of t is equal to 2t of 2t cubed minus 6t squared times of t squared minus 6 all over 4t to the power of 6. When the object is stationary, that means v equals to 0. And that's the same of saying that the derivative of the distance is equal to 0, because the derivative of the distance is the velocity formula. If you remember from last year calculus, we have so distance differentiates to velocity, velocity differentiates to acceleration. So velocity is the rate of change of distance, acceleration is the rate of change of velocity. So therefore, if you differentiate distance, you'll get the velocity function, so the rate of change of the distance. And when the object is stationary, then the velocity is 0. So we're going to set it to 0. So 0 equals to 2t of 2t cubed minus 6t squared, t squared minus 6. So 0 equals to 4t to the power 4 minus 6t to the power 4 plus 36t squared. So that is equal to negative 2t4 plus 36t squared. And therefore, we can say that 2t4 equals to 36t squared. Let's divide through by t squared. So we have 2t squared equals to 36. 2t squared equals 36. Getting slightly different before, so we have 2t. I think I made a mistake somewhere, so I have 2t multiplied by 2t cubed minus 6t squared, t squared minus 6. Two t. Sorry, just apologies. Give me a moment. I think I might have 2t times 2t. No, okay, this should be fine. Apologies. So we have t squared equals to 18. So let's take the root of both sides. So t equals to plus or minus root 18. So in this case, let's just simplify the radical a little bit. So we know that root 18 is 9 times 2. So we have t equals to plus or minus root 9 times root 2. So t equals to plus or minus 3 root 2 seconds. However, notice that t equals to negative root 3 on 2. It does not make any sense. So that's smaller than 0. So that doesn't really make any sense. And we say that t is greater than 0. So we're going to exclude this as a solution. Therefore, t equals to 3 on root 2 seconds. And that should be a merit level question if you can find the correct answer. And usually, if you can find a correct expression for the velocity, so the derivative, that should be achieved. So, question D, a rectangle has one vertex at 0, 0, and the opposite vertex on the curve y equals to 6e to the power of 1 minus 0.5x. X is greater than 0, as shown on the graph below. Find the maximum possible area of the rectangle. So for this question, we're going to just write out the formula for the area of a rectangle, and that is area equals to base times height. Notice that for this rectangle, the length here of this side here will be x, and the length of this side here will be y. And what is y? Y is exactly equal to the point on the graph at x, because if we have x here, then we have the point on the graph of y of x here. So therefore, area equals to x times y, and area equals to x times of y of x, which is given here. See if I copy that down correctly. 6e 1 minus 0. Yeah. So area equals to 6x e to the power of 1 minus 0.5x. And let's find the derivative and make equal to 0 to find the maximum. So we can find the derivative dA on dx. We're going to use the product rule again, since we have 6x times e to the power of 1 minus 0.5x. That's going to give us 6e to the power of 1 minus 0.5x. I'm going to add that to the derivative of e to the power of 1 minus 0.5x times 6x, which is negative 1/2 times of 6x e to the power of 1 minus 0.5x. Negative 1/2 times 6 is negative 3x e to the power of 1 minus 0.5x. And let's set this equal to 0. So let's solve for dA on dx equals to 0. So let's factor out e 1 minus 0.5x. So we're left with 6 minus 3x. Likewise, before with question 1e, we know that 1 minus 0.5x is greater than 0, so not equal to 0. So this is not equal to 0. So we're going to solve for 6 minus 3x equals to 0, and therefore 6 equals to 3x, so x equals to 2. So for x equals to 2, we can now substitute back into our equation to find the maximum possible area. So let's find the maximum possible area. Just do it here. So area equals to 6x times of 1 minus 0.5x. Area equals to 6 times 2 times of e to the power of 1 minus 0.5 times 2, which is 0. So that's just 12 units squared. It says that you do not need to prove that the area you found is the maximum. However, if you wanted to prove that the area is a maximum, you would simply find the second derivative of the area with respect to x. So the second derivative, you would plug in the value of x equals to 2. If the value is greater than 0, then it's a minimum point. And if the value is less than 0, then it is a maximum point. So for this question, if you find the second derivative and make equal to 0, you would be expecting that the second derivative will be less than 0 in order to give you a maximum point. So we expect that the second derivative, when you plug in x equals to 2, is less than 0, basically. This should be another merit level question, with the correct answer being a merit level grade. Let's get a better pen here. In terms of getting an achieved, usually if you can get the correct expression for the area and find the correct derivative, that should be enough for an achieved. So if you can get up to this step here, that should be grounds for an achieved grade. The curve of the equation y minus 5 whole squared equals to 16 times x minus 2 has a tangent of gradient 1 at point P. The tangent intersects the x and y axes at points R and S respectively. Prove that the length RS is 7 root 2. So for this question, we're going to find the derivative, and then once we have the derivative, we're going to substitute in the gradient equals to 1 to find the x value of point P. So we know that the gradient is 1. We can use this to find the x value of the point. However, we know that the point also lies on the curve, so we can use the initial equation, to find P. And then we can use the initial position to find P, because we know that the equation of a line is y equals mx plus c. And we can use point P as an initial condition, so P as initial condition. And then we're going to use using some line intersections, we're going to find the length of PQ, length of RS. Alright, so let's differentiate first to find dy on dx. So for this question, we have y minus 5 squared on the left-hand side. So in this case, I really much prefer use implicit differentiation, because when you take the root, you have like the positive root and the negative root, and that makes your life a lot more difficult. So I would recommend you just use implicit differentiation in order to evaluate this expression. So we have y minus 5 squared equals to 16 times x minus 2, I believe it was, yeah. So we're going to use implicit differentiation. So we're going to differentiate the left-hand side with respect to y, and we're going to differentiate the right-hand side with respect to x. So we have 2 times of y minus 5. And when you differentiate y, remember y is actually y of x. So when you differentiate, you gotta also multiply by the derivative of y of x, which is dy on dx. Okay, since this is an expression of y of x, when you differentiate with respect to x, you're gonna get the derivative of the inner function, which is whatever this inside is, and you're gonna have to multiply by dy on dx. So just remember, you have to multiply by dy on dx. The derivative of x minus 2 is just 1, so that's just 16. So therefore dy on dx is equal to 16 divided by 2 times of y minus 5, and that is equal to 8 rather. That is 8 over y minus 5. So let's substitute the gradient equals to 1, and then in this case we'll be finding the y value of where the gradient equals to 1. So I did say x before, but in fact we're actually finding the y. So in this case, y equals to 8 over y minus 5. Y minus 5 equals to 8, so therefore y equals 13. So that's great. We now know that y equals to 13 at this point P, and we can use the initial equation to find the x value. So we have 13 minus 5 squared equals to 16 times of x minus 2. So therefore 64 is equal to 16 times x minus 2. Divide both sides by 16, so 4 equals to x minus 2, so x equals to 6. This is fantastic because now we have the point P, so P is actually 6, 13. And we know that the gradient of the tangent is 1, so we can say that y equals to x plus c. That's going to be the equation of the tangent. So therefore we can substitute the point P, which is 6, 13, into our equation of the line. So 13 equals to 6 plus c, so c equals to 7. So therefore we know that y equals to x plus 7. And that's really good because now we can find the intersection of x plus 7 with the x and y axes, and we can use that to find the length of the line of RS, I think it was. Yeah, we can use it to find RS. Beautiful. Okay. So in terms of intersecting with the y-axis, so intersection of the y-axis is when x equals to 0. So let's find intersection y. So that will be y of 0, which is basically going to be when x equals to 0. So it's going to be 0, 7. So intersection with x is when y equals to 0. So we're going to substitute y equals to 0. So if y equals to 0, then 0 equals to x plus 7. So x equals to negative 7. So the intersection with x, that's going to be equal to negative 7, 0. And now we want to find the distance of RS, which is the distance between these 2 points. And that should be pretty straightforward. We know that the equation of the distance is square root of y1 minus y0 squared plus x1 minus x0 squared. So in this case, we're going to be having, if we do y minus x, then we're going to have like 0 minus negative 7 squared plus 7 minus 0 squared. So that's our distance. Distance equals to 7 squared plus 7 squared is 2 times of 7 squared. And in this case, we can bring out the 7 squared from the square root, so we're going to get d equals to 7 root 2. And that is as required as rs, so rs equals to 7 root 2, which is exactly what we found. And therefore, we know that we've done this question correctly. So this will be an excellent level question for finding the distance is 7 root 2. I'm pretty certain that a merit level grade should come if you can find the equation of the tangent. So y equals to x plus 7, that should be enough for a merit. And if you could correctly differentiate implicitly to find dy on dx, that's this point here, that should be enough when achieved. Question number 3, we're going to differentiate y equals to e to the power of 4 square root of x. So in this case, we're just going to be following any other rule with e to the power of something. We're going to find the derivative of the power, multiply by the power, and keep everything else the same. So I'm going to rewrite this as y equals to 4 e to equals to e to the power of 4 root of x, which is equal to e to the power of 4x to the power of 1/2. So dy on dx is equal to the derivative of 4x to the power of 1/2, which is 2 times of x negative 1/2 e to the power of 4 root x. And you can just leave your answer like this, or if you want to be a little bit more pretty, you can rewrite this as this. That looks a lot better, but it doesn't really matter since you do not need to simplify your answer. And this should just be a simple achieve question here. Question B, the graph below shows the function y equals to f of x. So for the function above, find the values of where x is not differentiable. So for not differentiable, we're going to be looking at sharp points and values where the function is not defined. Also points where the function is not continuous, that's also where the function will not be differentiable. So in this case here, let's have a look at this graph here, this f of x here. So looking at x equals to -4, I see a problematic point at x equals to -4 because we see that at x equals to -4, the function is not defined. So the function is not defined at x equals to -4. So therefore, it cannot be differentiable at x equals to -4 since it doesn't even exist at x equals to -4. So how can we possibly find the derivative there? Okay, so that's this point here. That's definitely not differentiable. I see another problematic point at x equals to -1. That's going to be a very sharp point there, so that's not going to be differentiable. And I'm going to see another sharp point at x equals to 1. That's also not going to be differentiable because the graph is not smooth. Alright, so the values of where x is not differentiable, I'm going to write x equals to -4, x equals to plus or minus 1. Find the values of x when f dash of x is 0. So that's when the rate of change is 0. So when the gradient function equals to 0. Or in other words, graphically, this means that there is a flat line. So where is a flat line on this f of x? I can see a point at x equals to -3 where there is a flat line. So it's here. I can also see that for when x is greater than 1, there's going to be a flat line. So when x is greater than 1, the gradient function is equal to 0. And that is all the points. We have x is greater than 1, and we also have x equals to -3. What is the value of the function as x approaches to -4? So in this case, we're going to have a look at the function as it approaches -4 on both sides. So as it approaches to -4 on the left-hand side, as we go from here, we can see that it approaches to the value of 3. And let's look at as it approaches from the right-hand side, it also approaches to the value of 3. It doesn't matter that the point at x equals to -4 isn't defined, as long as we know that the two graphs approach to the same value, then the limit will exist. So in this case, the limit exists and it's equal to 3. So it's going to be 3. And this should be a merit level question. So if you can get all 3 parts correctly, that should be a merit level question. And any 2 parts, that should be achieved. So if you can get 2 out of 3, that should be achieved. The diagram below shows the cross-section of a ball containing water. When the height of the water level in the ball is h centimeters, the volume v centimeters cubed of the water in the ball is given by v equals to pi times of 3/2h squared plus 3h. Water is poured into the ball at a constant rate of 20 centimeters cubed per second. Find the rate in centimeters per second at which the height of the water level is increasing. Find the rate in centimeters per second at which the height of the water level is increasing, where the height of the water is 3 centimeters. Alright, so we have a simple related rates of change question here. So we're given that the dv on dt is 20. That's the rate of change of the volume. And we want to find the rate of change of the height, which is dh on dt. So for these types of questions, I like to, first step is just to rewrite dh on dt as an expression related to dv on dt. So we have dh on dt equals to dv on dt multiplied by something. So you want to cancel out the dv, so we want to put dv on the bottom here. And we want to introduce dh, so we're going to put dh on the top here. So in order to find dh on dt, we need an expression for dh on dv. And that is very, very simple since we already have an expression for v in terms of h. So we can just find the derivative and then find the expression for dh on dv. and we can find dH on dt. So dV on dH is equal to pi times of the derivative of the h's inside. So we have derivative of 3 on 2h squared, that's just 3h, and plus 3. So therefore, dH on dV would be the inverse, which is 1 on pi times of 3h plus 3. And therefore, dH on dt equals to dV on dt, which is 20, multiplied by 1 on pi 3h plus 3, which is equal to 20 on pi 3h plus 3. And we want to find the rate of change of the height of the water level when the height is 3. So we're going to substitute h equals to 3 into dH on dt to find the rate. So we have dH on dt equals to 20 divided by pi times of 3 times 3 is 9 plus 12 plus 3 is 12. So we have this. And that is going to be equal to 5 on 3 pi, which is approximately 0.5305 centimeters per second. Since height is measured in centimeters, we know that the rate of change is centimeters on seconds. Alright, and that should be our final answer for this question. And getting the correct answer here should be a merit level question. And to get an achieved, if you can find an expression for dH on dt, that should be enough for an achieved. Right. Find the x values of any stationary points on the graph of the function y equals to 9x minus 2 plus 3 on 3x minus 1 and determine their nature. So for this question, it's very simple concepts used from level 2. It's just going to be given a slightly harder function. So in this case, we're just going to differentiate, make equal to 0, find the x values, and then find the second derivative, substitute these x values into the second derivative, and then using the second derivative test, we're going to evaluate whether or not this is a local maximum or a local minimum. Alright, brilliant. So let's have a look at y equals to 9x minus 2 plus 3 on 3x minus 1. The derivative is y dash equals to 9 plus of, in this case, we're going to have negative 3 over 3x minus 1 squared. So I did that quite quickly. So if you were to do it slowly, you might rewrite y equals to 9x minus 2 plus 3 times of 3x minus 1 to the power of negative 1. And you can just use the power rule for all of these cases. So 9x goes to 9. And in terms of 3 times of 3x minus 1 to the power of negative 1, you can multiply by negative 1. So we have negative 3 times of 3x minus 1 to the power of negative 2. So you bring the power down by 1. And then you will multiply by the derivative of the inner function, which is 3. I actually forgot to do that. So we're going to multiply by the derivative of the inner function, which is 3. So, and then we're going to bring the power down by 1. So we're going to get 3x minus 1 to the power of negative 2. So that is equal to 1 over 3x minus 1 squared. So y dash equals to 9 minus 9 of 3x minus 1 squared. And we're going to make equal to 0. So we have 9 on 3x minus 1 squared equals to 9. So therefore, if we divide both sides by 9, we're going to get 1 over 3x minus 1 squared equals to 1. So 1 equals to 3x minus 1 squared. And in terms of what we have now, we will have... we probably need to expand out. I was looking for a simple way to possibly manipulate it, but no, we're going to have to expand this expression. So we have 9x squared minus 6x plus 1. The 1 and the 1 will cancel each other out. So we have 0 equals to 9x squared minus 6x. So let's factor out x here. So we have x, 9x minus 6. So either x equals to 0 or x equals to 6 over 9, which equals to 2 over 3. So let's just double check that none of these values are going to end up with an undefined function. So let's substitute x equals to 0 into y. If we substitute x equals to 0, then the denominator here is not equal to 0, so that's okay. So let's try substituting x equals to 2 over 3. 2 over 3 times 3 is 2. 2 minus 1 is 1, which is not 0, so that's also okay. So both of these points are okay. Alright, so let's do a second derivative test by finding the second derivative. So let's find the second derivative. So in this case, we have y dash equals to 9 minus 9 times of 3x minus 1 to the power of negative 2. So y double is equal to negative 9 times negative 2 is positive 18 times 3x minus 1 to the power of negative 3 multiplied by 3, which is equal to 54 over 3x minus 1 cubed. Let's substitute x equals to 0 to start off with. So we have y double dash of 0 equals to 54 over 0 minus 1 is negative 1, so negative 1 to the power of 3. That is equal to negative 54. Negative 54 is less than 0, so therefore this is a local maximum. So this is a maximum point. If we do y double dash of 2 over 3, that's going to be equal to 54 over 2 over 3 times 3 is 2. 2 minus 1 is 1. 1 to the power of 3 is 1, so 54 over 1, and that is positive 54, which is greater than 0, so this is a minimum. And that's us done for this question. So we found the x values of the stationary points, and we determined their nature. So we have x equals to 0 is a maximum, and x equals to 2 over 3 is a minimum. This should be a merit level question. And if you can find both the points and classify them as maximum and minimums correctly, you will get a merit level grade. And if you can find both the points x and x equals 0 and x equals to 2 over 3, that should be equal to achieve grade there. Megan cycles from her home H to her school S every day. She rides along a path from her home from point P at a constant speed of 10 kilometers per hour. At point P, Megan cuts across a park, and when you cycle across the park, she only cycles at 6 kilometers per hour. At what distance from her home should she choose to cut across the park in order to make her traveling time a minimum? So at the start, this question might seem really complicated, but in terms of what exactly is this question is just finding an expression for the total distance traveled, and then classifying that distance as the distance traveled on the gravel and the distance traveled in the park. And once you have classified those two distances as the distance on the gravel and the distance on the park, you can then use the speeds, which is 10 kilometers per hour and 6 kilometers per hour, to find an expression of time in terms of the distance. And once you have that, you can just use your standard differentiation to differentiate may equal to 0, and then find the optimum x value for when she should cut across the park. So let's make a couple of definitions here. So let's define something here. So let's define x as the distance, as the point she cuts into the park. So basically, I'm just calling this point here point x. And therefore, since the whole gravel road is 4 kilometers, we know that PQ is equal to 4 minus x. And that's just basically 4 minus x plus x is 4. Alright, so looking here, we have a right angled triangle here. So we have 4 minus x and 2. And we have the hypotenuse is the distance in the park. So we have PS here is equal distance in park. And what is PS? PS is just we can use the Pythagoras theorem. We can just find c squared. So we have the PS equals the square root of 4 minus x squared plus 2 squared, which is 4. That is equal to square root of x squared minus 8x plus 16 plus 4. And that is equal to square root of x squared minus 8x plus 20. And the distance traveled on the gravel is x. As you can see, the HP is the distance in the gravel, which is x. So we can say HP equals distance in the gravel, which equals to x. So now, like we've said, we've classified the distance in the park and the distance in the gravel with respect to x. And now we can find a formula for the time. So the time is simply the total distance divided by the speed. And we have both the speeds of Megan in the park and the gravel. So time would be x divided by 6, which is the time in the gravel, plus 1 over 10 times of the time in the park, which is x squared minus 8x plus 20. Sorry. So now we can just differentiate and make equal to 0, and then find the optimum x value of when she should cut across to the park. So we have... Oh, did I get it the wrong way around? I did get it the wrong way around. I apologize. Sorry, guys. Okay, so x on 10 and x 1/6 here. Okay. So dt on dx is equal to 1/10 plus, in this case, we have 1/12 times x squared minus 8x plus 20 to the power of -1/2 times 2x minus 8. And this will be equal to 1/10 plus 1/6 times of x minus 4 over square root of x squared minus 8x plus 20. So let's make this equal to 0 and solve for x. So we might need some extra space here. Okay. We have plus 1/6 times of x minus 4 over square root of x squared minus 8x plus 20. So therefore, -1/10 equals to 1/6 times of x minus 4 over square root of x squared minus 8x plus 20. And if we multiply both sides by 6, we'll get -3/5 equals to x minus 4 divided by square root of x squared minus 8x plus 20. So let's move the square root to one side. So we have -3/5 times x squared. Square root of x squared minus 8x plus 20. That is equal to x minus 4. And let's square both sides. So we have 9/25 times of x squared minus 8x plus 20. That is equal to x squared minus 8x plus 16. So 9/25 x squared minus 72x/25 plus 180/25 is equal to x squared minus 8x plus 16. And if we rearrange this and move everything to the left-hand side, the right-hand side, we're going to have 0 equals to 16/25x squared minus 128x/25 plus 44/5. If you solve this equation in your calculator, you can also use the quadratic formula. In fact, if you're in the exam, you probably should use the quadratic formula just to prove that you know how to do it. But for me, I'm just going to take a shortcut here. I'm just going to say that x equals to 2.5 or x equals to, what was it? I forgot the second value, but the second value would not be valid. But I think it was... Yeah, or x equals to 5.5. Yeah, but clearly 5.5 is greater than 4. Remember that the total distance of the gravel is just 4. So having cutting into the park at 5.5 just doesn't make any sense. It's not logistically a thing. So it's like, in terms of the real world, we know that that's going to be not a real solution. So therefore, we can say that she should cut the grass at 2.5 kilometers. Probably park is better. No, after 2.5 kilometers. And that should be our final answer for this question. And this should be an excellence level question for finding the final value of x, which is 2.5 kilometers. In terms of getting a merit level grade, if you can find an expression of the derivative of dt over dx and then make it equal to 0, but maybe you made like a small mistake when solving the equation, you can still get a merit level grade. So like minor error, that could be a merit. In terms of an achieved, if you can find an expression for time, I think personally, if you can find an expression for time and then differentiate that correctly, that should be an achieved. So if you can get up to this step here, so dt over dx here, that should be an achieved. And that's all the questions we have here for the 2022 differentiation paper. I hope you all enjoyed. If you have any questions, please leave it down in the comments below. And I hope to see you all in the future.